testing, where you've got different platforms, different operating systems, printers, cohabiting applications, network connection speeds, and so forth, and you want to test the proper workings of some sort of web-based application or something. All of that stuff should allow the application to work, but in some particular cases, things might be in the way. So that's pairwise testing, and that's discussed, as I said, in that other webinar, which is available, recorded version. But what we're going to look at here is a situation where the factors actually are supposed to interact. There's a defined way for these values to interact. So they could be 10 values on an input screen where a couple of them are used to decide how the rest of them are to be handled, and they get put together into some sort of equation or something like that, and some value is calculated out of it. Classic example here would be if you think of the way that a tax package calculates your taxes. So you have is you're gathering up a very large number of factors, some of which are just plugged directly into calculations, some of which are used in calculations and also are used to determine the kinds of calculations that are done. So for example, you've got adjusted gross income that's going to determine the tax bracket that you're in. And so all of those factors have to interact properly. And so what we're going to do is we're going to use domain analysis to actually analyze the way in which those factors have to interact. And rather than say, well, there's a million possible combinations of tax calculations here based on equivalence partitioning and boundary value analysis, you say, no, we're going to do that. We're going to analyze the interaction itself and actually look for bugs based on the interaction. So that's where we're headed here for the next few minutes. Now, just the phrase domain analysis a lot of times scares people, but this really isn't too terribly complicated. Let's try to start off with a really simple example here. Get up Mr. Highlighter. Okay. Now, one of the things that I do a lot of is fly around on airplanes all around the world, and so definitely something I'm very familiar with are frequent flyer programs. And the way that the frequent flyer programs work is really ingenious. I mean, you're all, I'm sure, aware of the fact, even if you don't travel much, that you get points, or quote-unquote miles, that are redeemable for various kinds of things, most popularly free travel. And you accumulate those points, and then you use them at some future point in time. Sometimes they have expiration dates and so forth, but I'm not going to get into this whole question of expiration at the moment. What we're going to look at this point is this idea of a status level. Okay, now almost all of these frequent flyer programs have this concept of a status level. And basically the status level is a very clever marketing way of locking you in to a particular vendor. And the way that works is that you don't just get a mile for every mile flown or a kilometer for every kilometer flown, but as you fly more frequently with the airline over the course of the year, they actually start to give you a bonus. So it's fairly typical for there to be 4 levels in a frequent flyer program. One is none, you have no status, and that could be, you flew less than 25,000 miles or 40,000 kilometers or what have you over the last year. And then you get silver, which is the next step up, and then you get gold, and then you get platinum, and that's fairly typical. And the bonuses are, you get no bonus at no status level, of course, because you haven't put in enough miles with them. But at the point at which they decide, okay, now this is actually an interesting person. This is somebody who's flown 25,000 miles with us. So A, they fly fairly frequently, and B, they choose to give a significant amount of their travel business to us. So we're going to give them a bonus. We're going to give them another 25%. They fly 4 miles, they get 5. You get to the next status level, next tier, gold. Okay, now get 50% bonus level. So fly 4 miles, you get 6. And then platinum, 100%, they're actually going to give you 8. And you see how this has the effect of locking you in, because you're going to get disproportionately higher amount of rewards on the airline that you give most of your business to. So the idea is that you will pick an airline and you use based on that. Airlines have a real love-hate relationship with these frequent flyer programs. They work, but it's kind of like not only is the traveler sort of addicted to these things based on the tier levels, but also the airlines are addicted to it because the travelers come to expect it and no one can give them up. So, as I said, kind of a love-hate thing. So what we see here, we got distance traveled, right? So that's one of the factors, and then status level, that's another factor, and then there's points awarded, which is another factor. And the way that that works is we have the points awarded is equal to D times the 1 plus the trip bonus, which is determined by the status level. So we've got 4 factors there that are interacting. Basically, the status level is determining the trip bonus, and then the distance traveled is interacting with the trip bonus to determine the number of points that will be awarded. So you can see these things are not independent. And the quick thought exercise here would be, well, would it make sense to test just minimum and maximum status levels, right? Boundary value status levels, and then the minimum and maximum distance travel? Well, no, because that would leave out some important calculations. Well, what we're going to do is we're going to say, well, we've got these status levels, we've got the distance, and we've got the bonus, and then the points awarded. And we're going to look at the way that the number of points awarded could be miscalculated. Because if the points awarded is miscalculated, then something's broken. Either the status levels are being set wrong, or it's not recognizing the correct status level based on the number of miles, or the distance traveled is not being captured correctly. But that's going to be the points going to be calculated based on those 3 things, and so we're going to test that. In order to do that, we'd have to make sure that we tested at least 1 trip for each of the travelers' status levels. Okay, so here's a way of looking at that, right? We could draw 4 lines here. Now, let me get my happy highlighter up here again. The bottom line here is this guy. That's the none, and then we have, pardon my rather sloppy drawing, but so much you can do with a mouse. That's silver, and then this one here is gold, and then this guy up here at the top, whoops, is platinum. All right. And so what we're saying, domain analysis says that we just have to test 1 point, one distance traveled, and then verify the points awarded on each of those 4 lines. Now you might be looking at this going, okay, that is kind of like the decision tables, because in the decision table we could look at the status and based on the status, the calculation, and it would do the same thing. And it's indeed, you could implement this as a decision table if you wanted to, and it would end up driving you towards the same kind of testing. But the thing with decision tables, you're usually looking at I guess non-continuous, more discrete kinds of things. Domain analysis is more looking at calculations, like you're seeing here, where it's calculating the number of points to be awarded based on basically 3 numbers, right? One number is constant, number 1, and then there's a percentage bonus, which is determined by a variable that is discrete. It's the status level. But then the 3rd variable is the distance traveled, and that's a continuous variable, or at least it's an integer variable probably. So the assumption here is that we're going to test these calculations, right? We're going to try to identify values that would be sufficient to make us think, okay, we've tested these calculations. We believe the calculations are correct. Now notice that the whole accepting valids, displaying valids, rejecting invalids, somehow indicating an invalid output,